Okay, this is T24, the constant and power rule. All right, so if I look at it, the first thing they start off with is the graph of this line. And we know that this line is constant, right? And we know it's constant because it's what type of line? Starts with an H. It's horizontal, right? So it says if I call this function f of x is equal to c, where c has to be some number, right? What is the derivative of f of x? Well, derivative in calculus stands for slope, right? So basically they're asking me for the slope of this line. Where if it's horizontal, what did we say? The slope of a horizontal line is always equal to 0. So the constant rule, this d over dx is another way of saying the derivative in terms of x, right? The derivative of c in terms of x, in this case, we know is 0. Well, does it matter to c? No, because c is any number. No matter what value for c I make, whether it's going to be a positive number or a negative number, that means it's going to be a horizontal line going through the y-axis. So no matter what the c value is, the derivative, the slope of that line is going to be 0. So the derivative of a constant function is always 0. So no matter what the constant is, it's going to always, the slope is going to always be 0. So the power rule, there's a video that I made that talks about the proof of the power rule. So the derivative of x to the n in terms of x, we learned from the video, is n x to the n minus 1. Meaning I bring down that exponent to the front of the x, and I subtract 1 from the exponent n. So those are the two rules. If I have a constant, the derivative of a constant is 0. And if I have an x raised to some power, the derivative is to bring that power, which we call an n, to the front, to be multiplied to the x, and raised to the n, subtract 1. So if I look at this example, example 1, find a derivative of f of x, which is equal to 2x squared plus 3x minus 6. Well, that's 3 different terms, right? So all I'm going to do is take the derivative of each one separately. So f prime of x is going to be the derivative of 2x squared plus the derivative of 3x minus the derivative of 6. So 2x squared, what does this 2 matter? Well, if I'm bringing the exponent down in front of the x and I already have a number there, then what I have to do is multiply to that number. So this 2 is going to move down in front of that 2, and 2 times 2 equals 4. So it's going to be 4x to the 2 minus 1, because I'm subtracting 1 from the exponent. Then plus, because with derivatives, it's closed under addition and subtraction, meaning I could just take the derivative of each term. The derivative of 3x, this is understood to be x to the first power if I don't see an exponent. I'm going to take the 1 and multiply to the 3, because that's the number that's in the front. So that's 3. Then x to the, I do the exponent that was there minus 1. Right? And then minus the derivative of this number right here, a constant. What's the derivative of all constants? It's always just 0. So now if I go to simplify this is going to be 4x. 2 minus 1 is just 1 for my exponent. So if I don't write it, it's understood to not be, to be there, right? So then plus 3. Now 1, so this is x to the 1 minus 1 is 0. But what's anything raised to the 0 power? Well, the rule states that whenever I raise something to the 0 power, it's equal to 1. So this is really 4x plus 3 times 1, where x to the 0 is equal to 1. And what's 3 times 1? That's just simply 3. So my derivative here is 4x plus 3. So just from that, I now don't have to do the difference quotient. I could just use my power rule. So let me do number 2, one like number 2. And this is saying find the derivative of f of x equals 1 over x squared. So the way I do this, I have the x squared at the bottom. The only way I could do the power rule, I have to have everything in the numerator. So that means that I'm going to have to make this go to the numerator. Well, if I flip this to the numerator, what has to happen? Well, the rule states whenever I change the position of a term, if it's in the denominator and I switch it to the numerator, I have to change the sign of my exponent. So 1 over x squared is the same as x to the negative 2. So now I'm able to do my rule, f prime of x is going to be equal to, I'm supposed to take my exponent and bring it to the front. So there's going to be a negative 2 being brought to the front of x. Is the understood number is 1. There's no shown number. So it's just negative 2 times the 1. And then I'm supposed to do the old exponent minus 1. Well, what's negative 2 minus 1? Well, that's negative 3, so it's going to be negative 2x to the negative 3. And essentially, I don't want any exponents. So I want to flip that to the bottom, and once I do, it makes it positive. So either negative 2, sorry, I forgot my negative sign, negative 2 times x to the negative 3, or negative 2 over x to the third power, meaning I flipped it to the denominator and it became positive.